All right, so we're going to talk about areas of parallelograms and triangles today. But before we jump into that, we're going to first remind ourselves about areas of rectangles and squares. So here, you can see in the first two objects here, this is a rectangle, here's a rectangle, and here's another square. If you remember, the area of a rectangle or square was the product of its base times its height. And the base and the height were like length and the width. So I could say that here's my base for the first rectangle, and the height had to be perpendicular. Okay? And usually for a rectangular square, it was the side. So here, again, base, height, base, height. And remember, the base doesn't necessarily always have to be the longest side either. I could have very easily said for the second rectangle that this was the base and this was the height. Okay, so area of a parallelogram. Here I have two parallelograms. If you remember that they're quadrilaterals, and a good way to describe them is they're kind of like a rectangle, but slanted. Okay. Now they can be slanted the other way around as well. Oops. Let's flip this. Like this. Right. And a parallelogram still has a base. So you pick a side, and that would be its base. However, the height can be is any line segment perpendicular to the base. So there's the height for that first parallelogram. For the second parallelogram, put it on the outside here. So there's the height. Now, sometimes you can have it on the outside. You just have to extend that base a little bit so that it symbolizes that it's the height. What is the area of a parallelogram? The area formula is still base times height. And yes, it is the same as a square and rectangle. And I'll show you why on the next slide. So here we have three parallelograms, and I'll label them. Here's the first one, second, and third. All right, let's take a look at that first parallelogram. What we're going to do is we're going to try to find a way to cut that parallelogram and change it into a rectangle. But before I do that, I'm going to label the base, and I'm going to draw in and label the height. So here's my height. So where my base is. And you can see that along that height, if I cut along that, I get this triangle here. And if I take that triangle and I were to cut it, I can move it to the other side, and you could see that we get a rectangle. And that rectangle has the same base and height as the parallelogram. So that reinforces that idea that the area is simply just the base and the height. To prove it again, we'll take a look at a parallelogram number 2. And I'm going to label the base here, and I'm going to label the height. So here's where I'm going to put my height this time. And again, I'm going to cut along that height, creating two pieces out of my parallelogram. You can see if I can just slide that triangle up to the top and reconnect it to the other piece, I will get another rectangle. And that rectangle has the same area and height as my parallelogram. We didn't add or subtract anything. We just moved it. So take a look at this third one and see if you know where you want to cut to get a rectangle. Right? So you can pause it here and take a look. All right, next thing, area of a triangle. So most of you guys know what triangles are, what they look like, three sides. Right, here's a, looks to be an acute triangle. Here's an obtuse one. And remember, bases are any side. So I could label this as my base in the first triangle, and in the second triangle, I can label this side as my base. The height, remember, is always perpendicular to the base. So here's the height in the first triangle. Now in the second triangle, the height for that particular base has to go on the outside here. And you'll see that often for a lot of problems. And you'll see an extension of the base to verify that that is the height. Now, what is the area formula? Area of a triangle is 1/2 times the base times the height. I'll clean that up a little bit. So area equals 1/2 base height. So let's figure out why that is. Here I got two triangles. First triangle, second triangle. If I look at that first triangle, let's label this side as the base. So then my height will occur right in the middle here. And if I cut, I'm going to get two pieces, two triangles actually. And I can rotate this triangle so that it fits with the other side. And you can see we get a rectangle. And that rectangle, what's the base of that rectangle? Well, the base of that rectangle is the base, right? That base is half the base of the triangle. So area equals half the base times the height. And you can count the squares. You can see that in the original triangle, the base was 4. And in the rectangle, the base is 2. So 4 divided by 2, or 4 times a half, is 2. Let's take a look at the second triangle and verify that. Let's say that I make this side the base. Since this is a right triangle, here's my height. Remember that for a triangle, you want to cut along that halfway point for the base. So let's count out how long is that base. 1, 2, 3, 4, 5 squares. So about 2.5 then. Here is about where that cut line will occur. And I'm going to draw that triangle in. So we see we already verified that we cut it in half. We can see when I connect it here, I'm going to get another rectangle that has a base that's half the base of the triangle. So again, area equals 1/2 base times the height. All right, so there we have area of parallelogram and area of triangles.